Problem 8 AMC 10A 2005. In the figure, the length of side AB of square ABCD is square root of 50 and BE is 1. What is the area of the inner square EFGH? So I immediately see that there are four particular right triangles right here. And I know they're right triangles because it says the inner figure is a square. So it must consequently mean that they're all right angle triangles. And I want to find some sort of relationship between each other in order to help me find this out easier. And is there some way to do so? And the answer is yes. In fact, all four of these triangles are congruent to one another, and I'll be proving it to you on the right side of the screen. So first of all, right out the way, we know that their angles are right. So 90 degrees for each of the right triangles. And we know that this is a square. So the hypotenuses of each of the right triangles are congruent to one another. Now, what else can we deduce? Let's suppose this angle HAB to be x. Therefore, what must be the angle of ABH? Well, angle ABH, if I call it angle y, must be equal to pi over 2 or 90 degrees minus angle x, because the sum of the interior angles of a triangle is equal to 180, or pi. Therefore, this angle is as such. Now, angle y plus angle CBE must be complementary to one another, correct? Therefore, what must be angle CBE? Well, angle CBE must be equal to pi over 2 minus y, which is the same thing as pi over 2 minus parentheses pi over 2 minus x. And this gives us x, showing us that angle CBE is equal to x. So this angle is indeed x. Now, what is angle BCE? Angle BCE must be complementary to angle EBC, and you can see now where I'm going with it. With the same logic, angle BCE must be pi over 2 minus x, but we let y be equal to pi over 2 minus x. So this must be equal to y, must be equal to angle ABH. So we have seen here that this pattern must follow for the rest of the right triangles, which you can obviously deduce on your own. And now that we have this out of the way and we have all three angles, interior angles, within the right triangle to be congruent to one another, and we also have a side length of the right triangle. Therefore, we can use angle-side congruency to prove that all four of these right triangles are indeed congruent to one another. Now, this is a detour from the main problem, but this is important to understand because without this, we will not be able to solve this question. And with this out of the way, that must mean that all three sides of each of the four respective right triangles must be congruent to one another. In particular, segment 8H, segment AH must be congruent to segment BE. And we're given what segment BE is. BE is 1. Therefore, AH must also be equal to 1. And now we can use Pythagorean theorem to solve for the overall height. So if I draw this rough right triangle, AH is 1. The hypotenuse is, is the square root of 50. So by Pythagorean theorem, if I let the height be b, b must be equal to the square root, or I won't jump steps, I'll just solve it manually. So 1 plus b squared is equal to the hypotenuse squared. B squared is equal to 49, hence b is equal to 7. We take the positive square root because the side cannot be negative. Therefore, the height is 7. That must mean HE is 7 minus 1, which is 6. And the area of a square is one of its side length squared. In this case, A is equal to 6. Therefore, the area is equal to 6 squared, which is 36. And we see here that the answer choice is C has 36, making sure that C is indeed our right answer.